This video is on area polar region, and here I have two curves. And what I want to do is find the area of the region that is common to both curves. So we want this region, and then we want this little region right here. Here are the graphs of the curves. 2 plus 2 cosine of theta, and then r equal to 2 minus 2 sine of theta. And so we want the area of this region right here, and then we want the area of this region. And then we also want the area of this little region right here. And so first, let's find the points of intersection. So we need this point right here, and then we also need this point, and then we also need the points at the theta at the pole. And so to find the intersections, so we can set the two equations equal to each other, and then minus 2 from both sides, and then we end up with the sine of theta over cosine of theta equal to negative 1. Sine of theta over cosine of theta is tangent of theta equal to negative 1. And we know that tangent of 3 pi over 4 is negative 1. Tangent of 7 pi over 4 is negative 1. Tangent of 11 pi over 4 is also negative 1. And then so on. And then the points here at the pole, since the two curves they cross, they intersect with the pole several times. So we can set the first equation right here equal to 0, and then solve for theta. So set from here we get cosine of theta equal to negative 1. And we know that cosine of pi is equal to negative 1, of 3 pi is equal to negative 1, and then so on. And then also we set the second one equal to 0, and from here we get sine theta to be 1. And we know that sine of pi over 2 is 1, of 5 pi over 2 is 1, and so on. And so it looks like the graph intersects when the two curves they intersect at theta equal to 3 pi over 4 at 7 pi over 4. And so let's draw these two lines so we can get some boundaries. And so this is the line theta equal to 3 pi over 4. And then let's draw the line theta equal to 7 pi over 4 and see what it looks like. It's the same line. And so what I'm planning to do is for this region right here, what we can do is find this area, half of it, this piece right here. So we can find this half of it, which is this piece. And then double it So just find half of it. And then this piece right here is bounded by this curve, which is the line by the blue curve, and the line theta equal to 3 pi over 4. And then we'll do the same thing for this piece. We'll just find half of it and then double it. And then that will give us the shaded region. And then in order to get this piece right here, I have to play with the theta with several values of for theta, and then I ended up with pi. So theta from pi to 7 pi over 4, and then we will get this piece. So to generate this piece, set theta equal from pi to 7 pi over 4. Because we know that the graphs intersect when theta is 3 pi over 4 and 7 pi over 4. And so now we can set up the integral to find the area for this piece right here. And so the area for this region right here will be 1/2, and then f of theta squared, and then theta will go from pi to 7 pi over 4. And then the blue curve, that's the curve r equal to 2 plus 2 cosine of theta. And then from here, simplify, we get 4 plus 8 cosine of theta, and then plus 4 cosine squared of theta. Multiply by 1/2, we get 2 plus 4 cosine of theta, 2 cosine squared of theta. And then let's just integrate each expression separately. So for the 2 here, and then we'll get the integral of 2, just 2 theta, and then evaluate from pi to 7 pi over 4, then we get 3 pi over 2. And the integral for 4 cosine of theta is 4 sine of theta, and then evaluate from pi to 7 pi over 2, then we'll get negative 2 times the square root of 2. And then the 2 cosine squared of theta, recall that cosine squared of theta is 1 plus cosine 2 theta dividing by 2. And then we just get 1 plus cosine of 2 theta. And then the integral would be theta, and then the integral for cosine of 2 theta is 1/2 sine of 2 theta. And then evaluate from pi to 7 pi over 4, and then we end up with 3 pi over 4 minus 1/2. And so the area for this region right here is going to be 3 pi over 2 minus 2 times the square root of 2, and then plus 3 pi over 4 minus 1/2. So this is the area for this piece right here. And then now we also need the area of this piece right here. And so same thing, we'll just find the lower half and then double half and then double it. And so to find this piece right here, I grabbed from theta equal to 3 pi over 4 to from theta equal to 3 pi over 4 to theta equal to pi. And then we'll get this piece of the graph right here. And so the area for this region right in here is going to be 1/2, and then the integral from 3 pi over 4 to pi. And then the curve, the blue curve here, is the function is 2 plus r equal to 2 plus 2 cosine of theta, and then squared. And just like earlier, this simplify, we get 4 plus a cosine theta, 4 cosine squared theta, and then multiply by 1/2. And then we'll integrate each piece separately. And then the 2 here, the integral will be 2 theta, and then evaluate from 3 pi over 4 to pi. Then we get pi over 2. Integral for cosine of theta is sine of theta, so we get 4 sine of theta. And then evaluate from 3 pi over 4 to pi, then it's negative 2 square root of 2. And then just like earlier, for 2 cosine squared of theta, then we'll rewrite cosine squared of theta as 1 plus cosine 2 theta over 2. And then we'll end up with pi over 4 plus 1/2. And then let's call the area for this region, let's call it a sub 2. So it would be pi over 2 minus 2 square root of 2, and then plus pi over 4 plus 1/2. And so in summary, the area for this region right here is this part. And then the area that's half of this right here is this part. And then combine everything, we get 3 pi minus 4 times the square root of 2. And then, which is approximately 3.76. And then the area that is of the region that is common to both curves, then we just double this value right here. And then double it, then we get 2 times 3 pi minus 4 times the square root of 2. And that comes out to be about 7.53. And that's the end of the video.